I am the Modality Manager for injectors and also the instructor for service training on injectors. Today, I'm going to discuss for the next 45, 50 minutes on the basic troubleshooting on contrast injectors, primarily their Medrad line of injectors. They think they are the most common injectors out there in the field, and ironically, they have the most problems. Troubleshooting injectors can be difficult, cumbersome, and actually frustrating to most when you don't quite understand what you're looking for. So again, welcome, and here we go. The models we're going to talk about today are the Stellar, Solaris, Mark V Probus, and the Mark VII Arterion. We're going to start with the Stellar injector first. That has the most problems with it, only for the fact that it is abused quite a bit in the healthcare industry because it's used all the time in the CT scanner. First, we're going to talk about the 1 or 2 causes of issues with injectors. The number 1 cause that takes an injector down is contrast. Contrast gets everywhere. If you ever had an unfortunate time to clean an injector, you will know that contrast goes everywhere. The Stellar injector and all the injectors have gaskets in them to prevent contrast intrusion into the circuit boards, the sensors and such. But they do fail and they're not waterproof. So contrast will get in there and cause you a lot of problems. The number 2 cause, and I hate to say this, is operator misuse. Now, I'm not saying they do it deliberately, but they do damage the injectors. Either they run into the wall, into the overhang, or even crush the table on them. That can happen. So those are your 2 major causes of issues with injectors, any injector: contrast intrusion and user abuse or misuse. We're going to start off with some basic troubleshooting guidelines, or actually any troubleshooting, but this is primarily or is geared towards the injectors. Things to remember while troubleshooting an injector. I was taught in the U.S. Army back just a few years ago, 92, that when you're troubleshooting, you have to start with something. So what they always told us was, got it, don't got it. When you don't got it, go back to where you got it. And somewhere between got it and don't got it is your problem. And that's where you narrow your search down to, or your troubleshooting. Whether it be power coming out of the wall, like it won't turn on, okay? Do you actually have power coming out of the wall? You do. Take it to the next step. Do you have power to that power strip? Now, we all know power strips are never, ever used in the hospital, but someone could turn it on or turn it off. Now, you have no power, and you follow right up to your injector, and then if you have power to the injector, it's an injector problem. You move from there. So got it, don't got it, there's your problem. So when you approach an injector, the first thing you want to do is, of course, talk to the customer, but do an operations check. Try to duplicate the problem. If you can duplicate the problem, great. You can key in on what you were doing, what happened, so on and so forth, and you can narrow your search down. Also look at what works, what doesn't work. Sign A works, sign B doesn't work. Does it turn on? Does the screen turn on? Well, the screen turns on, but the injector doesn't turn on. So what works, what doesn't work? When did that error occur? Well, every time I turn the injector over to inject, I get a 311 error. There's the key. Every time they turn over to inject, something happens. Is that in the display? Probably not. Power supply? Probably not. It's in the head someplace. Like I mentioned before, side A or side B, or both. And has anything changed recently? Now, I put that in there for a specific reason. About 6, 7 years ago, I trained some students, and they were on the East Coast. And about 3 months later, one of my students called me up and said, "Hey, Mike, every time they go over 6.5 milliliters per second, they overpressure. I said, well, what injector is this on? It's on a Stellant. Huh. So we researched it, and come to find out that our purchasing department decided to buy a cheaper grade of tubing. And that cheaper grade of tubing was a smaller diameter. And if you understand pressure, then a smaller diameter increases pressure quicker. And looking at the label, it stated right on there for 6.5 milliliters or below. So when they were trying to do a 7.5 CTA study, it would overpressure every single time. So what has changed recently? Are they using the same brand of disposables? Are they using the same brand of needles? All that can affect the operation of the injector. Now there's two different types of error codes on the Medrad injectors that pop up on the screen when there is an error. Both of those are useful to you. And when they're combined together, you can kind of narrow your search down a little bit. So they have the SIM code. We've all seen that SW code. There's ENCA code, MOTB code, and POTA code. What do they mean? There's many more of those. But, what do they mean? Well, SW means software. It's usually not software, it's something else, and the injector doesn't know what it is, so it's like a check engine light. It just tells you something's wrong. ENCA, encoder A. MOTB, motor B. POTA, potentiometer A. That gives you a good guideline of what, not necessarily causing the problem, but what is affected by the problem. Then you have your EERM numbers. Those are what the customer's going to usually call you and say, I have this code. It's 1306, or it's 1806, 1805. Unfortunately, the bare manual service manual doesn't give you those codes. But we've all seen the 311. If we haven't, you haven't worked on injectors, I'll put it out. But error 311 shows that it's with the SW a software error. It's not a software error. It is actually a critical voltage out of tolerance. Now, why does it give it a software error? Because the software doesn't know where it's at, it just knows something went wrong. That's your check engine light. It could be your gas cap, it could be your O2 sensor, it could be anything. Unless you know the code, it's not going to help you much. But 311 is a critical voltage out of tolerance, not software. Critical voltage out of tolerance. Just remember that next time you see a 311 code. It's not software. 1806, I do believe that's going to be the encoder error, and the 3026, that's a tower error. I'll get more into those as we get to the slides. But there's two types of error codes. They just sit right on top of each other. So we're going to start to talk about the Stellant. Now, there's several versions of the Stellant. There's what we call the legacy Stellant. It's the older display that we have up on the screen that I have right here. And then we have the newer Integra Workstation. The only difference between these two injectors are the displays. Power supply and the header are the same. So you can troubleshoot them the same. And that's one thing about Bayer. They don't change error codes from one injector to another. A 311 on a Stellant is the same as a 311 on a Mark 7 as on a Solaris. A 311 is a 311. Okay, we're going to talk about the top end sensors on a Stellant. So here's the top end right here. This is where your syringe goes in. We have three sensors. 1, 2, and the tip right here. Those are your three sensors that identifies and monitors the position of the syringe. Those are the error codes 21, etc. So whenever you see a 21, it's at the top end. I just want to make sure I stay on track with everybody here. Interface errors, syringe, or FRA flex rings on each side. So what you have here is a sizing sensor, also called an optic sensor. This sensor says there's a syringe present. It's the right syringe. Inside, you have the flex spring sensor. So once it sees a syringe, the next question is it positioned properly? Once that is established, then the piston is going to drive up until the docking pin hits the plunger in the syringe. That is where your volume starts. So if you put a syringe in and nothing changes, it never stopped the syringe. If you put the syringe in and it starts to move, you get interface error. It's the interface sensor inside the head. If the first two are satisfied, it's going to try to find that plunger in the syringe. And you may get a docking pin stuck error. That may happen also. So you have three different errors, all by putting the syringe in. You understand what that machine is telling you. Side A, docking pin stuck. It's right here. It's not here or here. It's that docking pin. If nothing happens when you put it in, or unrecognized syringe, then it's your optic sensor or sizing sensor. Same thing, just called different things. If you snap the syringe in, the ram piston starts to move, and you get an interface error. That's inside of here, where your flex springs are. So it's not positioned right, or needs a calibration, or usually it just needs a good cleaning. So those are the three sensors in the top end. Now let's talk about pressure issues. Power issues. We have 3026 and 3028. 3026 is power side A. Now when the injector boots up, it looks at side A first. It sees if the power is satisfied at side A, which is 48 volts. If it doesn't, if there's no power there, it'll give you a 3026. If you read the OEM's manual, it'll tell you to go to your power driver card or check this, but it never tells you to check the power supply in a power module. And that's just right back here. Okay? That gives you the 48 volts to the injector head. So when you have a 3026, the first place you're going to start is right at the power module and right at the 48 volts. And 48 volts is fluctuating any way whatsoever. It's not at 48 volts, solid 48 volts, that power supply is bad. And that will give you intermittent errors all over the place. But if you get it on boot up, 3026, you're going to check your power module, check your power supplies. And the first one you're going to check is going to be the 48 volts. Oh, did I move that? I apologize. Okay. Then you have power 3028, which is just the B side. So what can we, I hate to say assume, what can we assume when you get a 3028? It already checks the A side, right? And A side said, I'm all good. Okay, so now we have an issue on the B side. So what are you going to check first? Are you going to check the power supply? No, the A side is fine. You're going to go straight to the head and start checking your voltages on the head. So 3026 is the box. 3028 is in the head. Just keep that in mind also. Select, okay? Common errors. Software, SW311. Very common issue, right? Critical voltage out of tolerance. Side X, in other words, A or B, is not docked. I've seen that many times. I installed an injector in state, I don't want to say the state, but they went to fill the syringe and they called me up like 45 minutes later. Oh, side A is not docked, side A is not docked. Well, what they didn't do was they didn't manually increase that piston up to hit the plunger. The last motion was a, I'm sorry, was a withdrawal, not extended, okay? So if you withdraw your, if you fill your syringes, and then if you don't, the last motion has to be a forward motion. If it's not a forward motion, you're gonna get side A or side B knocked out. So just, again, remember that. It's a very common problem if they manually fill their syringe and don't use the autofill. They forget to move that piston up to find the plunger. Syringe sensor, A or B, that's what these two are. Remember, we talked about that a few slides ago. Do I have a syringe? And if I do, it's the right syringe. Hover error, common, it's your overlay assembly. Contrast gets them on the circuit board in the back, in through here, and starts sorting it out. Hover error is a stuck key. It's usually on the injector head. It could be a dirty touch screen or a stuck button on the stator step, okay? Software error, anything with a software error, it's very, very seldom software. It is just a generic code that they throw out saying something's wrong, we don't know what it is. So don't automatically think, I need to reload software, I need to have Bear come in and reload software, I need a new CPU board. That's not necessarily the case. If something else is wrong, you just have to try to dig deeper into it, figure out what it is. And when you do that, again, it goes back to your basic troubleshooting. When does it happen? Is it on boot up? And what is that ERM number beside, underneath of that? That will help guide you in the right direction. Blank screen. Here's a good example. You go to turn on your screen. Maybe not. I apologize for that. But if you go turn it on and it's just a blank screen, just the backlight, what that is it's not communicating with the head. It just sits there. So it will not boot up until it communicates to the head. Once it communicates, it will boot up. So check all your connections. A blank screen is either going to be mismatched software, which I doubt that is going to happen because you haven't changed anything around, or you have a bad connection someplace. Along with the 1319. 1319 can give you a blank screen also. It'll just come up and go 1319. A 1319 is also a bad connection. A lot of times, just reseating your cables will go ahead and resolve that issue. So we're going to talk about the type of workstation now. And this is a newer system out there. I'm sure a lot of you have this out there and have seen it and are confused by it or unsure about it. I received a call today, a tech support call, and they had a power issue last night, and they came in and the type of workstation was on, but the injector was off. They didn't know the injector was off, they just thought the whole injector was down. Well, the Integra display works off its own power supply. And if it loses power and turns back on, or power is reapplied, it'll automatically boot up. But the injector won't. These two systems act independently. So to turn the system on, you want to look for this amber light. If you have no amber light, you have no power going to the module. You want to go back to your power module and look at your 15-volt power supply. No light, no power. Look for your power. To turn this on, it's very important to watch the boot sequence. If you don't watch what's going on or understand what it's doing, then you can get very confused. So you hold the amber button down for about 2 to 3 seconds. It's going to boot up, you're going to see the lights come on, you're going to hear the noise, and it's going to start booting into Windows. As it boots up, you want to watch the screen. You'll see down here it's red, it's black. It's talking to the head. When it actually makes communication to the head, it's going to turn red. and then it's going to boot up. If it sticks at loading software, it's never communicating. Don't take a head from the legacy and put it onto a Certegra. The Certegra will download software to it, and you can't take it back to the legacy. Keep that in mind. But the sequence on the stuff is very, very important. And they'll continue to do it. Okay, let's talk about the Solaris EP. So the Solaris EP has its own system talking to its display. The only communication that the two have is through a fiber optic cable. And it's important that the fiber optic cable acts as the old style crossover cable. Now, if you're old enough to remember a crossover cable, if we're talking computer to computer, you know that cable crosses over. Transmit to receive, receive to transmit. That's how the fiber optic cables are supposed to be connected. Not R to R, T to T. R to T, R to T. Crossover. I've seen that many times, many tech support calls, that the cleaning crew come in, or the other crew, the CT crew, or the MRI crew has changed stuff around, and they disconnect and connect those cables, the fiber optic cables. Well, those fiber optic cables can also get damaged, and if they are moved, they can be put in incorrectly. They are keyed, and they just can't push in. But some people try to do that, and that damages the actual receiver and transmitter of the fiber optics. So, again, handle them like glass, because there is plastic in there, the regular fiber optic cables. And that's what you need to take away from this is they act as a crossover cable. There's no power. It is just communication between the injector head in the MRI and the display in the scan room, in the control room. Mechanical issues. The motor and encoder are in the base. The pot and the gears are in the head. Does that seem to be a problem? Yes, it is. And when they create an error, it doesn't exactly tell you what that error is or where that problem is. It'll tell you the potentiometer has the error in the head, but is it the potentiometer or is it the motor and the encoder? It just tells you there's a problem in a mechanical drive circuit. So you have to troubleshoot that mechanical drive circuit. Driver errors don't always point to the problem. It points to what the circuit is. And you have your encoder, your potentiometer, and your motor error. They all work together. Interface errors. That's the top up here where you put the syringe in. What usually happens is we get syringe interface errors. Everyone goes right to the top here to look. Very seldom do they get damaged unless you damage them yourself by not paying attention to what's going on or put it incorrectly. Usually there's an interface, well, not usually, there is an interface board right in the center. Everything is fed to that interface board, to the head cable, down to the pedestal, to the base interface board. So just because it says syringe error doesn't mean the syringe, the interface is bad. It is anywhere in that communication circuit. That goes for potentiometer, that goes for also the pressures, everything all runs through the head cable, which is a bunch of wires all wound together. The newer MR Experion has done away with that. They use fiber optics to top from the head to the base. So that's going to be a lot easier to troubleshoot. Intermittent errors. This is something to remember when you're troubleshooting Solaris. If you have intermittent errors bouncing back and forth all over the place, it is usually your battery. Whenever I have those symptoms, I always find a good, known battery that I trust. If you have to spend the money to get one in overnight, it is well worth the money to spend. Because there's nothing more frustrating than trying to troubleshoot with poor equipment or with a battery that is not fully charged or is not holding a charge. Give it a known good battery and start troubleshooting. Keep that in mind. 311s, communications dropping in and out. When you go to arm it or during an injection, it drops out and it shows a power issue. It's your battery. Get a good known battery that makes all it is. If it's not, you know you're starting with good equipment to troubleshoot your injector. So next, let's go ahead and start with the Mark V Probus here. Well, that's over here. Now this is a beast. And it doesn't tell you a whole lot to troubleshoot. So you kind of understand the circuit. Check head cable, PL. It's not the head cable. It's in the plunger circles. The random goes up and down. It's not the head cable usually. This is a very sturdy head cable, and it's not like the Stealth that breaks all the time. So it's in the plunger circuit. That's where your issue is, not the head cable. The next one is check head cable MS, mechanical stop. So the plunger was working fine, but the mechanical stop is having the issue. So troubleshoot the mechanical stop issue, not the head cable. In my 15 years or so of working on injectors, I have replaced 3 head cables. And that's only because they ran over it with a table or a gurney. It wasn't because it was actually damaged from use. Establishing communication, that's a good one too. You turn it on, it just says establishing communications. Nothing happens. But the injector head turns on, but nothing else happens. It just sits there and says establishing communications. Reseat your boards. Down underneath in the control cabinet, reseat your boards. They normally don't get pulled out and so-called clean. Some of us old timers remember that if you reseat boards and clean up all the contacts on it, just doing that can solve your problem. A roll of boards pushed in firmly. If you were just doing a PM and you get an established communication, you check your boards. I was working with one guy and he said, I checked my boards, check them again. I checked my boards, check them again. He wasn't pushing them in all the way. These are very hard boards to pull out and push in. You think they're in, but they're not. I had some guys say, it feels like I'm breaking it. Well, push a little harder, and guess what? It fixed it. So reseat the boards. Boards not reseated correctly. They could have been in the wrong spot. Like I said, if you're just doing a PM on it, you pull a board out to inspect it, they can go in the incorrect spot. Luckily, that cabinet is labeled on each side on what the boards go, where the boards go. PPI memory failure. They should not necessarily PPI card, although I would, if you want to buy one for about $2,700, I'll be more than happy to sell one for you. But if you get PPI memory errors, you want to short out or clean the memory on the PPI board. And that could be at that connector, JQ1 or S1 on the pedestal S1, and you want to just clean it up, a clean start. And then your battery, your 3-volt battery, can also be draining or failing low voltage, and that can cause PPI memory errors. So those are 2 things to check out. DAC errors, digital analog digital converter, SCC card. If you get DAC errors, it's the SCC card. Servo control card. That's what controls all that information. Okay. And if you get those errors, I think that it's DAC overload or DAC overvalue, then it's your SCC card. Now you see all these boards here? This is old electronics. Okay. All these boards now will be fit on 2 or 3 boards long. There's actually 2 more boards that go in here. So remember, when you're working on this, it's old technology. Every board has its own function, whether it be an interface board, CPU board, PPI board. That's the back. interface board, power supply card, mechanical stop card, or the motor relay card. They all do their own little function. Okay? Nowadays, half that will be on one board. This one is not like that. Keep that in mind. And now the Mark 7. The Mark 7 injector is one of the best ones that Barrett's ever put out. It's been around for, I think, maybe 10 years now, maybe not quite that long. They actually took all the good stuff from all the injectors. And like, if anyone has worked on a Manta, yes, this looks just like a Manta head. The Manta injector head was a good head. So they used that model put on here. Display is the old type of Stellant display. That works very well, so they put it on here. The power module, they did a fantastic job. There's only 3 boards in the power module and a power supply. They did a fantastic job. So common errors and issues. Very stable unit. Syringe switch. This is what's going to get you. What happens is in every cath lab that they always have a room set up for emergency. I'm sure you've seen that. It's always their emergency room. And so they have contrast ready to go. Everything is all ready to go. Well, there's the pin right in here. It's a syringe sensor. And the syringe goes in and pushes down on that pin. When they pull the syringe out, the pin pops up and the piston retracts to allow you to put a new syringe in. Well, what happens is if they have a leak in that syringe that's been sitting there all weekend long, the first case will go just fine. A contrast has leaked and actually glued this pin down. So when they take the syringe out, guess what doesn't happen? That piston does not retract. It's up here someplace. They can't get another syringe in, a new syringe. So they're down. And you get the call. Well, you take the pressure jacket off, and you get in there and you clean it, and it pops up. And then the piston retracts. It's just that simple. This is probably the #1 cause for service calls is right there, that pin. It gets glued down. Keep that in mind when you get, my piston won't retract. Huh. Do you have a syringe in it? No, we took the syringe out and my piston doesn't retract. It's not the switch, it's glued down there. Nice hot towels in there, we'll clean that right up. Don't pour water in it. Just a warm, moist towel will clean all that contrast off and it'll pop up. Motor drive boards, it's right in front here, right on the display. It handles a lot, it handles power and it handles a lot of amperage. It gets hot and it's abused because of the amperage it takes for the injections that they use. It will wear out and it will fail. Not hard to replace and not very expensive either. Like I said, they actually did a good job on this head. And you'll get motor drive error, and that goes straight to that board. And pretty much, this head is very solid. Power supply. Power supply is unique. It's in the power module, and in the power supply, it has a what they call a variable power supply. Now that can mean different things to different people. But what it actually means, it'll take 110 to 240 input off the standard plug. And it'll run. It automatically converts whatever power is given into the power that the injector needs. It does that through modules. And when one module goes out, nothing happens. It's a protective circuit in there. You have 348 volts bussed together, 348 volt power supplies bussed together. Gives you the amperage, and it gives you the power that you need. As a safety precaution, when one of those modules go out, nothing turns on. It won't even turn on. You don't have any power to the on-off button. Nothing. It stops. Check your power supply. Check your power modules. You remove that power supply, remove the power modules, and test each one and find out which is bad. Now, I did that one time, and luckily it was in training. I put a new 48-volt power module in it. And Stacy, if you're watching, I'm sorry, but when she plugged it in, we had flames going about 2 feet behind it. It just shot right out and blew components all over the place. It was quite an enlightening experience. So I highly, strongly recommend that you replace all 3 power modules. Bayer doesn't sell the power modules, they sell the whole power supply. Althea, we do sell the power modules. The power supply is not bad. Okay, there's nothing wrong with the power supply. It's the power modules that need to be replaced. And we have them here. There's also a 15-volt power module in there. Also that, if you're in there, might you replace all 4. But definitely, if you have a 48-volt power module that goes bad, replace all 3. Or if you want to, it's up to you, replace the whole power supply. But I can tell you right now that the power supply is not bad. It's the power modules. We can find that out the hard way. So this is a really good unit. These are the symptoms or the issues that I've had in the past. Only a handful of them. It's not that big of a deal to work on if you know what you're doing. And it's actually fun to do a PM on because it's a great little unit. So prevention. What can we do as technicians to prevent all these errors occurring on the damage and issues that we have? What can we do? What type of preventive work can we do to these injectors to maintain them and have them operational as much as possible? Well, training. Even though I am an instructor and I train on these, it's always nice to know what you're doing when you go to work on something. And I have been in a situation after 30 years of being in the business where your boss says, go look at it. And you're thinking to yourself, I have no idea what this thing is. And you get in there and you're looking at it and you try to look as intelligent as you can. And then you find a tech and say, can you turn this on and tell me exactly what it's doing? We've all been there, right? Okay. Show me exactly what you're doing, what you did when the error occurred. Well, go ahead and turn it on. Now, I actually need you to go through the whole steps so I can just see everything that's going on. So then they turn around and just push the button on the side and they kind of look at it. You're like, have you ever seen this before? Oh, yeah, plenty of times. Okay. I got the book, right? So training prevents that. Okay. And you're dealing with the imaging world, and they don't have 4 or 5 of these things laying around. They have one of them, and if you can walk in there and have good knowledge and be comfortable and be comfortable and confident in what you're doing, then you can sail through these things with no problem. But training is always helpful. Definitely is helpful. Complete and preventive maintenance properly. Don't just go in and do, yeah, it's working. Okay, we've all been there because your boss says here's 400 that need to be done by the end of the day. That's not right. A good preventive maintenance is what these injectors need. And what's included? Well, you need gaskets. Contrast is a hard material when it dries. So if you have a foam gasket and contrast gets in it, guess what? That gasket is no good. It's not doing its job, and now you have contrast going on to the circuit boards. Change the gaskets out. Well, it doesn't look bad. Do you change your oil filter every time you change your oil? Usually, yes. Does the oil filter look bad? Well, no, but you do it anyways, right? Same thing. Do a good preventive maintenance on it, and your service calls will drop dramatically. Here in the Tennessee area, I started a couple of years ago with Althea, and I started doing PMs on some of the sites here for Althea, and our service calls probably went down, well, to like a handful a year, when they used to be a handful a month, only because of good cleaning and good preventive maintenance on it. There's some injectors I haven't seen all year long, and we're doing PMs the next month or two. Haven't seen them. Good preventive maintenance will decrease your service calls. Daily cleaning. Train the CT techs, the MR techs, the angio techs to do daily cleaning. Daily cleaning will save a lot of frustration. When you do a PM, 75% of the PM is actually cleaning. There's no reason for that. Okay? Wipe it down. Take the pressure jacket off. Clean the pressure jacket. If they have a spill, clean it up. There's no reason why you should be walking on the floor and your feet sticking to the contrast on the floor. Okay? Train your techs, talk to your techs that keeping a clean machine will drastically decrease the downtime of that injector. Along with your preventive maintenance and daily, weekly, monthly cleaning, it is actually in their operator's guide to do this. And you can point that right out to them in a nice way. And educate the operators. Don't tell them, educate them. And by doing a good preventive maintenance, having good training, your injector service calls will be reduced drastically if you service them yourself and less need to call Barry. So let's talk a little bit more about maintaining injectors within your organization. Okay, what's the advantages? Okay, so an injector goes down. It's under contract with, let's say, the OEM. And you call the OEM, yeah, I can get there tomorrow. Now what happens? If the injector's down, they normally call the CT down. And the CT's down, then they have to reschedule patients. So that takes not only the inconvenience of the patient, but also takes time away from the schedulers to reschedule. And then they ask you, well, when is it going to be back up? I don't know. The OEM's not here yet. And then you start going around circles. And this is not counting revenue loss or patient frustration. This is just unseen expenses from having that injector down. But now you're servicing it. They give you a call. Most repairs on an injector take less than 90 minutes. Yes, less than 90 minutes. Why? What causes the problem? Contrast. How do you get rid of contrast? Hot, damp towel. That's how you get rid of contrast. It's not recognizing my syringe. Take it apart, clean off the optic sensors, put it back together, boom, you're done in less than 45 minutes. Meanwhile, you're still waiting for the OEM to call you back to schedule the service call. Or syringe interface error. Or, like the 1.7, my piston won't retract. Now you're waiting a day or even 3-4 hours, it doesn't matter. You're still down. Now that cath lab is down. And then everything just starts rolling back. So now you're servicing the injector in-house or within your organization. You're there, you fix it, they don't miss a beat. Select a good training program. There's other training programs out there besides Althea's. Now, I'll be honest with you, I have gone to some of those. And I was always disappointed at saying, isn't there more? Isn't there more than just doing a PM? Yes, there's a lot more. There's 364 more days more than just doing a PM. There's tearing the system apart, cleaning the system, putting it back together, troubleshooting, parts replacement. Althea US training, injector training, provides all of that. So when you leave our training, you are very confident and comfortable The key word is comfortable in working on these injectors. You want to walk in and says, I got this. And that's what Althea's training does for you. We tear these injectors down to the bare bones. We put them all back together. That gives you the confidence to walk into a sticky situation and take care of the situation. Take care of the patient. I mentioned before about all the behind the scenes costs. It's just not cost savings on a contract with Bayer. It's everything behind that. Okay, yes, you will save money by performing these services in-house yourself without a contract with Bayer. But everybody behind the scenes, when they have to start rescheduling things, you want to be able to go up to that radiology director and say, this is what the problem is. I have a part on order. It'll be here at 8:30 in the morning. So we don't have to cancel patients tomorrow. It'll be up and running by 11 o'clock. Great. That solves it. So in conclusion, let's wrap this thing up. Maintaining, troubleshooting, and servicing contracts injectors can be challenging, but with proper training and a little experience, you can deliver quick, competent service to your customers, the patient. Remember, the patient are our customers. So let's take care of them. Let's give them the treatment they deserve. And remember, got it, don't got it. Thank you very much. We're going to open this up for questions.
Thank you so much, Michael, for all of this valuable information. As a reminder, if you have a question for Michael, please use the questions feature on your webinar dashboard. We do have some questions that have come in, so we'll start with those. The first is, which injector model do you consider the most difficult to troubleshoot?
I would have to say the Solaris, because you are dealing with two separate pieces. And one thing about the Solaris, I'll bring it over here, there's no display to tell you what's wrong. So you have to actually understand how everything is put together, and when you got put together, how everything operates together, and think outside the box, think logically, if this is this, is this, and kind of piece it together. We had one here in dental repair that was very challenging, and there was a lot of things wrong with it, but we were able to finally pinpoint it down to where the problem was, and we were able to repair it. But that is the most challenging because it really doesn't tell you anything at the head. Next question.
All right, our next question is, when looking at the error codes and possible causes, how accurate are the probable causes?
I would say it gets you in the ballpark, and that is why when I was mentioning the troubleshooting, what works, what doesn't work. What are all the symptoms I have, and if I can put together what is actually working on everything, I can narrow it down to say, okay, if this is working, even though it's giving me the error, I can see that it's working, then there's something else. So it gets you in the ballpark. It's not like going into the garage with your car and saying, I hear a tick, can you fix it? No, it's actually saying, okay, I'm hearing a hissing noise, and so on and so forth. So anywhere between, I would say 75% close, but when you're talking about the motor, encoder, and pot, it could be any of those three. So that's why you have to kind of understand how everything works together.
All right, our next question is, how do you troubleshoot the Solaris EP injector when the injector head is in the MRI scan room?
Good question. We don't. We actually disconnect the cables, bring the Solaris head out, and in the training kit that I provide, you have a service fiber optic cable. So all work is done outside the MRI scan room, and you can actually take that injector downstairs to your shop or wherever it's